Hello, this is another video in our series of videos trying to explore what does it mean to have a trig ratio for an angle that is bigger than 90 or a negative angle, because those are outside of our right triangle. And that's where trig ratios come from, ratios of sides of right triangles. So how did mathematicians get trig ratios for these other angles that don't make sense in terms of a right triangle? What we've come up with so far is I can take any angle in standard position. It could be 120, it could be 375. Could be negative 5,000. And if I put it in standard position, the cosine and sine of that angle will be the same size as the cosine and sine of the reference angle. And then whether it's positive or negative will depend on what quadrant that terminal side of the angle is in, and whether the x and y there are positive or negative, because x and y relate to our opposite and adjacent. So let's take a little closer look at that just to sort of refresh. Okay, so for purposes of this, we're on our unit circle, but the radius could be anything, but we're going to assume that our radius is 1. So if I take an angle that terminates in quadrant 1, this is the easy one. So here's my angle, right? Shoom, it's going off at that angle. That's my theta. It's from the x-axis. Now I can talk about this point right here, which we call xy. And if I do that and I draw a triangle like this, this is the x-coordinate is that length right there. The y-coordinate is right there. And because it's a unit circle, we were going to say our hypotenuse is 1. And if that's true, sine of theta will be opposite, which is y over 1. It will be the y value. And in quadrant 1, that will be a positive number because y is positive. And that should make sense. This will be a positive number. Now, my cosine of theta will be the x-coordinate, because I'm going to do adjacent right here over hypotenuse, and I get x over 1, or x, and that will also be positive. Now we're going to move to an angle that terminates in quadrant 2. So again, it still starts from here, but my angle goes and it terminates. I'm going to pick one that's the same reference angle because we're going to talk about that too. So boom, I end right there. Again, this is now my point xy. Boom. Right, here's my theta. It's a right triangle. Oops, I didn't want to do that. Let's go back here. Okay. Again, if you think about this, here's my 1. That's still 1. It's still the same length as before. This is not theta anymore. This is theta reference, because theta is really the angle all the way to here. But theta reference, see that triangle is the same. The sine of theta is still the y, because it's still the opposite side. It's the y value right here. These are different x's and y's, but same size numbers, and that's going to be positive. Now the x-coordinate right here, this side, the adjacent side, is going to be x, but now x is going to be negative. It's going to be the same size as the x over here, but it's going to be negative. When I move into quadrant 3, when I come down here and I pick this angle, same angle, I have a new theta reference, but it's the same size. Theta, this red theta reference, this green theta reference are all the same size. As long as they're the same size, the ratio numbers parts will be the same. But now, when I'm down here, again, the opposite side is going to be a negative number. It's going to have the same y value, but sine will be negative. And when I'm here, cosine theta, again, this side right here, the x value is now a negative number. That's where I get those negative ratios. And I can do finally quadrant 4. What happens in quadrant 4? Maybe pause the video, see if you can figure it out. What do you think? If you're back, here we draw. Oops, not drawn very well on this one. Right, here's my theta reference. Again, this, well, that's not a good triangle, but this is still my y. Sine of theta, the y value down here is going to be negative. But cosine of theta, which is my x, the adjacent side, would be a positive number. And I get a positive ratio. So when I do this positive number over 1, because again, that's still 1. When I was over here, this would still be 1. Okay. So we're going to try some questions, some problems with some angles. We're going to put a whole bunch of things. All these videos, we're going to put them together in the next few questions, hopefully. Okay, so if I have the angle of 225, I'm going to draw the angle in standard position. Okay, so things that I know when I'm going to do this, I know that this is 0, and then we go to 90, and then we go to 180, and if I hit this, this would be 270, too big. So 225 is somewhere down here, right? So my angle itself is like this. And it goes around to there, okay? What we're going to do, though, is we're going to say, all right, trig relates to angles that I know that are less than 90. And it's going to be that angle. There's my reference angle. That's my reference triangle, okay? So what I want to think about now, and if we're on a unit circle, this would be 1. Now, I don't know how big these sides are, but what I know for sure is that that is a negative number, and that is a negative number. So sine of 225 is going to be a negative number. And cosine of 225 is also going to be a negative number. And you can check that with your calculator. You should see that that's true. So now my challenge question for you is, what's another angle that will have exactly the same cosine ratio? So there's multiple ways to do this. I want you to think about that for a second. Where else could you go? What quadrant could you go in to have the same cosine ratio? Let's try that. So where am I going to get the same cosine ratio, but be in a different place? And the place that I could go would be still on the left side. I still need my x coordinate to be negative. So I'm going to pick an angle that's the same size reference angle. Ooh, so I need to figure out what was my reference angle in this first one. When I was at 225, how far past 180 did I go? So I can quickly do 225 minus 180. Ooh, I have a 45-degree reference angle, which means I need this angle up here to be 45 degrees. So if I go back 45 from 180, I should get 135 degrees. So that is an angle that would have the same cosine ratio as 225 degrees. Check that on your calculator. How about, let's try the sine one quickly. Sine 1, sine 1. So the sine ratio, let's see, where would the sine be the same? Well, I need a negative sine. If I tried 135, my sine ratio would come from this length right there. That would be my opposite, and that would be a positive number. And this one was a negative number, so that won't work. So I need a 45-degree reference, but I need it in a different quadrant. I need a place where I would also have a negative y or negative opposite, and that's going to happen right here when I am 45 degrees away from 360. Ooh, so this one actually I could give you 2 options. I could try sine, if I want to be super tricky, of negative 45 degrees, or sine of whatever 360 minus 45 is, which turns out to be 315. Check those on your calculator. All right, let's try, not the challenge part, but let's try the other part of a couple more. So let's do this one right here. Ooh, negative 30. How am I going to do that? Well, first I have to draw the angle in standard position. So negative angles, we don't go counterclockwise, we go clockwise, 30 degrees, right there. And I'm going to make my, yep, I made my little triangle. This would be a positive side. This would be negative because I'm below the y-axis because the y. This is about the x is positive. This is about the y being negative. So cosine of negative 30 degrees should be a positive answer. And sine of negative 30 degrees should be a negative answer. Again, check with your calculator. And if you want, try the challenge. You can check that, your answer there with your calculator. We're going to do one more, just last level of trickiness. Holy moly. Ms. Kirstead, how do I do 460? Well, I got to think about where I am. So there's 0. This would be 90. This would be 180. This would be 270. Uh-oh, I'm still not there. This is then 360. I'm going around again. I had 90. This is 450. Ooh, I'm almost there. So I'm going a little bit past, right? So I go around all the way around once, go a little bit past 450, And if I added another 90 to that, that would be 540. Boom. Okay, but I would be here. And what I know, based on being in quadrant 2, is that sine of 460, if I'm up in quadrant 2, I have a positive y value, so I will have a positive sign. And if I did cosine of 460, you figure that one out? Right here, my adjacent side's right here. Is that a positive number or a negative number? It's going to be negative. Check that with your calculator. If you want, try the challenge. Come up with some other angles. Try and make it tricky angles. Push yourself as much as you want and check with your calculator. Okay, that's it for today.